and welcome to this afternoon policy session. My name is Niko Wirgentius and I come from Finland and I work for Fortum. So we are going to spend next 1.5 hours on building level where game is played, where competition exists on a heat market. So our focus is on energy performance of buildings. We all know that energy performance of buildings is one of key elements to improve energy efficiency and security of supply and also reduce CO2 emissions. Therefore, there are European-wide regulation and also voluntary mechanism to improve energy performance of buildings. Today we are going to hear what there already is in Europe and what there will be in the near future. Our speakers represent the best expertise around Europe, so let me introduce them. The first one is Eva Hoos from European Commission from DG Energy. She will tell us what is going on in European level related to energy performance of buildings. The second one is Boris Lubinski from AGFW, from German Association. He has been in Sen standardization process and he has the best knowledge about the combination of district energy and Sen standards. Then we have a Robin Wiltshire from BRE UK. He will tell us about the voluntary building certificates and especially about BREEAM. And then we have a fourth one, but unfortunately he is not here yet. He is coming as soon as possible. But his name is Guido Schwarzendahl, and he is a Chief Executive Director of a housing Co-Operative, Bauverein, Halle und Leuna from Germany. But okay, let's start. So please welcome Eva. The floor is yours.
Good afternoon. I will present the current implementation framework that we do on the energy performance of buildings directive and generally on buildings energy performance, and also the prospects for future action and direction from our side on this field. As an introduction, it is important for you to know that I am coming from DG Energy, the Energy Efficiency Unit that covers the entire energy efficiency field, products, buildings, financing, and horizontal measures. We have 4 teams, and there is one team that is dedicated to buildings efficiency. I am not member of this team. I am member of the team that is responsible for the implementation of the Energy Efficiency Directive, which also has buildings-related provisions. And because of the fact that we are working currently, as I will explain later briefly, on the review of the Energy Performance of Buildings Directive and a heat and cooling communication for Europe, and these have elements that may have synergies and impact on each other. Therefore, it was a decision that it is the best if I come and present the EPBD implementation as well as the next steps, although this is a very serious technical work that we do on the implementation of the various articles of the EPBD, and this is done in a different unit. So the legal framework is the Energy Performance of Buildings Directive and the Energy Efficiency Directive that have direct provisions concerning the buildings. Then we also have the Renewable Energy Directive, basically aiming to expand renewable use in buildings, heating and cooling and electricity systems. and the eco-design and energy labeling framework, which regulates product efficiencies. The specific legal framework that we need to implement is the EPBD directive, which is the recast version from 2010. Then the related methodology, framework methodology to calculate the cost-optimal energy performance requirements of buildings, and then guidelines on how to do this calculation, which is a framework calculation and should be implemented at national, can be implemented also at regional level. We consider that the building efficiency in an integrated way. So we are looking at the performance of the building shell, the climate, the building envelope. We are looking at the performance of the building elements and technical building systems. And we also consider buildings in terms of their relationship with the surrounding energy system, and we promote demand response and demand side management for buildings. So therefore, basically, all the specific energy efficiency legislation is applicable for buildings. The eco-design framework, which, for example, sets what are those products that are efficient in heating and cooling. Space heaters, water heaters are the most important products, perhaps from that sense, or lighting appliances. But we set performance for the entire building, performance requirements, buildings elements, and building units. And in a more horizontal approach, the Energy Efficiency Directive requires that buildings are renovated, public buildings are renovated at 3% per year between 2014 and 20. And it requires member states to also elaborate long-term building renovation strategies that would elevate the energy performance of the individual buildings and building stocks to the level that have been defined in the Energy Performance of Buildings Directive. So Energy Efficiency Directive and the EPBD are very closely related. So the EPBD is the main instrument specifically addressing building efficiency. And what are the key instruments? Member states have to set minimum energy performance standards for buildings, and these energy performance requirements should be reflected in building codes, in national and regional building codes. There is an obligation to issue an energy performance certificate for buildings and to make this available when a building is constructed, sold, or rented out. So the new owner or the renter can see what the building or the building unit performance will be. And there is the requirement to move towards the so-called nearly zero energy building standard, first in public buildings, starting from the beginning of 2019, and in the entire building stock, starting from the beginning of 2012. And this is underpinned by a benchmarking system to improve the level of ambition and keep it under review. So the minimum performance requirements need to be reviewed after member states have calculated them using the methodology, the framework methodology that the Commission has set. They also have to review these performance requirements every 5 years. It has taken a very long time to actually implement the basic requirements of the EPBD, which were already present in the 2001 version of the directive, meaning the energy performance requirements and the certificate system. And basically, it took 10 years to become standard practice almost for member states to issue energy performance certificates. and to integrate or start integrating building requirements, high energy performance building requirements into their building code. But today this has become something natural for people who are buying or renting houses or apartments to look at the energy performance requirement, and we are quite proud of it, that sometimes they don't even know that this is an EU requirement and that originates from the EU. But it took a long time, at least 10 years, and we still are not fully finished with the implementation of neither of the first EPBD nor the second EPBD. But if we are looking at the impact, EPBD is really a success story. We can see that since the first directive, there is a decreasing energy consumption in absolute and relative term in building stocks. And now this is basically a fact of life that buildings, heating, cooling, and electricity system are going to be becoming more and more efficient. We have currently the implementation effort is focusing on looking at whether member states have done their cost optimal calculation for setting minimum energy performance requirement, and whether these requirements, if they have done it and if they have done it properly, which is a very detailed and legal analysis that we are currently performing for the 28 member states, then whether these requirements are sufficiently reflected in their building codes. And the difficulty with the building requirements that in many member states, these are regional building requirements. So we also have to look at the regional level implementing measures and building codes. There is also a big focus for us to make use of the European Structural and Investment Fund for building efficiency and especially refurbishment of the existing building stock, which is also a requirement in the directive that member states should use European funds and help use financial instrument to improve the efficiency of buildings in their territories. So the basic requirements broken down by article is to calculate the methodology, which is quite complex and technical. So a cost optimal level of energy performance and how much it costs to get a building to a good energy efficiency performance. To set and ensure that minimum energy performance requirements are at this cost optimal level in their building codes. This also includes the requirements for building systems and the nearly zero energy buildings, which is basically for a requirement for new buildings, but also there is a requirement that the refurbishment, when a refurbishment of a building occurs, then this should move the building towards this nearly zero energy building standard. Financial incentives and energy performance certificates that are very important. We also have mechanism to ensure that heating and cooling systems are inspected yearly in each and every member states. We are also now checking whether member states are doing that. And there are many reporting, control and quality insurance requirement in the directive. For the calculation methodology, we have a general framework. Then we also work closely together with Sensenelec, and I think the next presentation will detail this type of work, how to define this the energy performance requirements of a building or a building element, a building unit. And we consider the work of Sensenelec as a way to help European level harmonization of the building performance requirements, which are very specific to climate conditions, to cultural traditions. So it's very much defined by member states, and member states even regions, what these performance requirements are. But we think that a harmonization of these requirements should be possible and build on the common element that anyway can be found in each building, no matter what the geographical location of the climate condition is. This is a very huge standardization work, which is happens under the umbrella of the so-called M480, which is a framework standard. And under this framework standard, if I remember well, there are at least between 60 and 100 detailed standard streams, standardization work relating to the entire building or the specific elements and units of the building. The cost optimal level is basically aims to ensure a high level of energy performance in the building. There is, as I said, a methodology how to do that, to take into account the savings that can be achieved in the buildings and then balance it with the cost. We have done an assessment of this, but a state of progress on the cost optimality requirement will come later, if I remember well. As regard near zero energy buildings, member states had to submit their plans how to increase the share of nearly zero energy buildings in their building stocks. But first and foremost, they have to define what do they mean by nearly zero energy building. There is a framework definition for that in the directive, that this is a very low energy consumption. The majority of this consumption should be covered by renewables. But each and every member states will have their own specific nearly zero energy building definition that should include a numerical value. For example, how much kilowatt hour per square meter per year this building would consume. And also some sort of quantification of the share of the renewables in the supply of the remaining heat load in the buildings after they have been transformed into these low energy buildings. We now have the definition from all the 28 member states. We are also analyzing the member states' reports and definitions. These are not easy to define, these buildings, and it takes a lot of technical work and preparation from member states to do that. Here you have a visual of the status that we see we are at this stage. Basically, we have definition in place in 13 member states. There are definitions that are waiting approval. Then there are definitions that will be developed, and there are no reports or translation available yet. But from the data we know today, it seems that member states define nearly zero energy buildings at a consumption of between 33 kilowatt hour per square meter and 95 kilowatt hours per square meter, and basically the mean would be 45-50 kilowatt hour per square meter per year consumptions. That would be the average nearly zero energy building concepts overall. And for non-residential buildings, it seems that the standards are much higher, and member states have difficulties to reduce the hospitals and other non-residential buildings consumption, to see solutions to reduce their consumptions to the similar order of magnitude than in the residential buildings. So the current values are quite high, to 270 kilowatt hour per square meter per year. There are also member states that so the nearly zero energy building standards are defined not in a very perfect way in most member states' case. So we will have a lot of implementation effort to align this with the requirements of the directive. And one of the issues is that they do not really include the share of renewables, or they do not specify concretely enough how much renewables they want to implement under the nearly zero energy building concept. However, some member states provide these values, and here you have a picture in these slides that some member states or some regions define the share of renewable at quite high level. Here you see the solar source share in the nearly zero energy building. But then there are member states that do not really define that renewable share. There is also a requirement in the directive to improve the renovation rate and to move towards deep energy renovation. So to ensure that the existing building stocks move towards low energy buildings. And from the national report that we have seen, we can group the measures that member states would like to see as instrument that can help this renovation to go towards the NZ nearly zero energy building concept. Of course, financial support schemes are the leading measures that they think is necessary to achieve that policy objective. Building regulation, the reliability and the strength of the building regulation is another important instrument, and from our implementation screening we can fully subscribe to that. Awareness raising and information for owners and users of the buildings and building units, education, training, demonstration, research and development, energy audits and energy performance certificates. The reliability of energy performance certificates, their visibility are also important measures that member states see to go towards the low energy building standard. We have done quite an important work to ensure that building renovation and the implementation of the EPBD and also the Energy Efficiency Directive gets sufficient EU funding from the European Structural and Investment Funds. And we got quite good results. We have doubled the EU funds from the previous financing period to 23 billion as a minimum, but member states have earmarked much larger amount of money for renewable energy and energy efficiency. And the Horizon, the research and innovation framework, research, development, demonstration, innovation framework has also become a very important instrument for building efficiency. We have a large number of calls dedicated to building efficiency under renewables, energy efficiency, industrial development and so on, and also to district heating and cooling. And overall, there will be some 5.6 million euro devoted to this theme. Then there are other energy efficiency funds for buildings, actually quite many. Life Plus is an important example, and then energy efficiency, European Energy Efficiency Funds and so on. Coming to the energy performance certificate on a bit more detail, this is, as I said, seems to be really a success story. Now we are in 2015, but we could see that after 10 years of the lifetime of the first EPBD, this energy performance certificate has become a natural element of the real estate market and the property market, and they have actually really contributed to increase the value of a building or increase the amount of rent that the owner can ask for a building or a flat that has very good energy performance. overall. So this has a value increasing property in addition to actually reflecting real energy savings if a building is at a high energy performance rating. Since for the implementation, we basically will go to ensure that all shell obligations are implemented literally and in spirit by member states. We will accept flexibility, of course, in those requirements where member states may do or may do not, may choose not to do it. But we will require basically very clear and concrete implementation measures. We will not lightly accept member states to use the technically functional and economically feasible clause, which is included in some of the articles of the directive. We will ask them to explain what does it mean, when do they consider technically functional and economically feasible is conditions are met or not met, and we'll actually are really performing very detailed analytical and technical analysis on these buildings. For the future is basically what we are looking for in 2016. We plan to review the energy performance of buildings directive, and in 2015, so this year, to come out with the heating and cooling strategy. The plan is that the heating and cooling strategy would set the direction for the EPBD review, which can include how to strengthen energy performance of buildings, whether these energy performance certificates should include additional elements on renewables, on smartness or district heating elements, how to ensure that renovation takes place, how we can ensure the speeding up of the renovation rate, and many other issues that are, for example, how to take into account the urban dimension of building performance and so on. So there will be the heating and cooling strategy, which sets the framework for the review, and the review will come out with the concrete legal measures that will lead, perhaps if needed, to the recast of the current EPBD. Thank you.
Thanks a lot, Eva. So I think we leave the discussion after all the presentations, so please mark your questions down there, and then we have a discussion after every presentation. But now we continue to implementation of this issue. So please, Boris, floor is yours.
Thank you, Niko. Ladies and gentlemen, before I start with the core of my presentation, which deals with primary energy factors, I want to talk about two aspects from the panel debate yesterday. The first aspect is, I think it was Eva, you said that in the European Parliament recognized the heating market as a Cinderella of the energy strategy. Was it you? Something like that. I like this picture very much, the Cinderella picture, because who's Cinderella? We all know Cinderella as a, on one hand, dirty, but hardworking, but never complaining character, very positive, and she's always honest, and she's always kind. And we all love the moment when she falls in love with the prince. So using this childish metaphor, if the heating market is Cinderella, I'm wondering about who's the prince? Okay, but it better fits to our industry. Another character from this world, I'm a big fan of Tinkerbell. You know Tinkerbell from Peter Pan? She is, because she's much more like our industry, she's finding smart technical solutions, just using things that other people throw away, so they regard as waste, and makes beautiful things out of it. And so I think Tinkerbell should be our mascot. Okay, that's for the metaphors. Another aspect that I want to start with is who was it? Lily. Lily from the United Nations Environmental Program. She said, DHC won't disappear from the agenda because the facts speak for themselves. So I completely agree with that, but I want to add, not only the facts speak for themselves, but the figures speak for themselves. And this leads me to the topic of my presentation. What are the figures and what do they show us? Some speakers already talked about primary energy consumption, primary energy factors. We all know this term, but in the panel debate today, I realized not all of us are really aware of what is primary energy. Some use the term equivalent to oil equivalent. So I would say oil equivalent is not the same as primary energy. So I thought maybe I start with the basic principles about primary energy. What is the primary energy approach? Or some in the standardization family, they call it the holistic approach. Okay, we start with the building. The building has an insulation. This basically defines the useful heat demand. Then inside the building, there are technical building systems to, for example, the little pipes inside and maybe a boiler or heat exchangers and so on, and ventilation. This is what we call technical building systems. And the third part is the energy carrier that crosses the system boundary, so the assessment boundary, basically. I try to point at it. There it is. I learned it today. I have a kind of laser pointer for 3 screens at one time. That's great. So energy carrier is delivered here to the building. And I will only talk about the energy carrier. I won't talk about the calculation of the whole building, but only what is delivered here with the energy carrier. And the basic idea of the EPBD is to set minimum requirements for primary energy demand in kilowatt hours primary energy per square meter and year. So all the 3 aspects are calculated together, and this can be subject to the national EPBD implementation in the national regulation. So we're now talking about the energy carrier. What is a primary energy factor of an energy carrier? This is a table showing some primary energy factors, and I briefly want to explain it to you because I recognize that we all talk about it has a primary energy factor of, but there are 3 different kinds of primary energy factors. Which one is meant? We have to distinguish between the 3. So what is the 3 primary energy factors? So I use the laser pointer again. So a primary energy factor is basically a figure, a value that can be placed here for any energy carrier that you wish. There we have FPREN says the non-renewable. P is always primary energy and F is factor. So this is the non-renewable primary energy factor. This is the renewable primary energy factor. And this is a total primary energy factor. They all belong together, and each energy carrier has 3 different primary energy factors. So as an example, let's pick out wood pellets. I look up in my table. A wood pellet is a biofuel. That's what I know. and its physical state is solid. So I know this table tells me it has the primary, a non-renewable primary energy factor of 0.2, a renewable primary energy factor of 1, and 1.2 for the total. So what's the difference between these three? In standardization process, we always we begin on the left for the energy source and then follow to the right the energy stream, the energy flow. And this is what we do with this figure. So in section A, this is the energy source in nature. And this can be the gray ones are the fossil fuels, and the renewable fuels, I made them in green. And in the source of nature, this is called primary energy. So energy that has not been subjected to any conversion or transportation process or whatever. So this is the primary energy, and then we use, we have an energy chain of processing the energy carrier, and then we deliver it to a point of delivery, which is here in section C. And the processing, like transportation, for example, is in our example case of wood pellets, getting all the wood out of the forest, then bring it by lorry to some factory, then process it, press all the sawmill dust, for example, to pellets, and I need additional energy expenditure, and this is allocated to the energy carrier. And all this additional energy expenditure is reflected in the numerator, because any primary energy factor is a ratio. It is a ratio of, in the numerator, the primary energy input, and in the denominator, it's always what is delivered to the point of delivery here. And I can do it in three different ways. Here, I take the whole primary energy. For the non-renewable primary energy, I exclude the renewable part. I only consider the non-renewable part, so the fossil part, the bad part, and put it into the numerator. And I can also, for the renewable primary energy factor, only take into account the renewable part. That's also possible. So it shows me that the total is always the sum of the non-renewable and the renewable primary energy factor. So these are the three types. But this was for an energy carrier like wood pellets or any fuel. What's the primary energy factor of district heating? That's much more interesting for us as an industry. And this is quite simple. As we have, again, the energy chain and the direction of the flow. So and the primary energy in the source of nature, so processing like extraction, refining, transport. Then the fuel is delivered to a district heating plant. There it is converted into heat. And then by a district heating system, it's distributed. And then here again is the assessment boundary of the building where we deliver it. And the primary energy factor of any district energy system is a composition of the upstream chain of the fuel and the system efficiency of our district heating system. It can also be district cooling, district electricity, whatever. And this brings me to the primary energy factor. So the calculation rules for the primary energy factor are subject of a European standard. And the European standard has a basic principle. So we have, in principle, we have two options how to get to primary energy factors of district heating. Option one is the use of default values. Default values like in this table. Option two is calculate the primary energy factor with your system-specific data as input for the calculation. So let's talk first about the use of default values. The use of default values is very valuable if you don't know everything about the district heating system. So you have a lack of information. In practice, we have it quite often that I don't know how much energy input was it, or how much heat did I sell to my customers like this. And for this purpose, lack of information is the option 1, the use of default values. So let's go into this table. No. I need my laser pointer. There it is. Let's stick to the wood pellets. Let's say we have wood pellets and burn it in a boiler without CHP, just to keep it simple. So I again go to my solid biofuel that I already know and go into this section of the table and see heat from boilers. There's always also a section heat from CHP, but I go to heat from boilers because that's all I know about my district energy system. And then I go into the table, and the table tells me, okay, for the heat that I deliver to the customer, I can use the value of 0.4 for the non-renewable primary energy factor, 1.4 for the renewable part, and the sum of these two, 1.8 for the total primary energy factor of the delivered heat. The basic principle is that all these values, of course, they are calculated somehow, but under assumptions that I would call they are conservative. So you can use these default values anytime. And if you're not, if you don't feel comfortable with the figures, like for example, okay, 0.4 is not good enough for my customers, you can go choose the second option and go to the calculation. And then, of course, you need to know the energy data of primary energy input and output. And this is shown in the next slide. So what is the basic principle of the calculation? It's also quite simple. We regard the district heating system as a black box. And the black box means I don't ask what's really inside there and what energy flows are inside the black box. I only have to know which energy flows cross my system border. And the system borders are usually defined by energy meters. So that's what I have to know. And then again, I make a simple ratio of primary energy input and delivered heat, and the result is my primary energy factor of my district heating. That's all. And when it comes to certificates and quality assurance that also Eva spoke about, we come to a certificate, a possible certificate. How can you display the energy performance of your district heating system? And I made one up for you just to showcase here. I just called it Central District Heating System of Green City, operated by Energy Efficiency Company, which is all of you. And the energy performance indicators here, primary energy factor, non-renewable, renewable, and total. Then you have the values, you put them on the certificate. And in addition, in your country, maybe emissions are more important than primary energy factors. You can also put emission factors on this certificate. And this all this comes from the EPBD itself. So I brought this little sentence, I read it out with you. The energy performance of a building shall include an energy performance indicator and a numeric indicator of primary energy use based on primary energy factors per energy carrier. That's exactly, the purpose is exactly this. And the second one, and now I jump out of the EPBD and into the Energy Efficiency Directive. There in Article 2, where's all the definitions, we have the sentence, the definition, Efficient district heating and cooling means a district heating or cooling system using at least 50% renewable, 50% waste heat, 75% co-generated heat, or 50% of a combination of such energy and heat. And for serving this purpose, we will integrate into the certificate these three: renewable energy ratio, the waste heat ratio, and the co-generated heat ratio, all in as a percentage. And this will be the certificate for district energy system. And this leads me to another aspect from yesterday, from the panel debate, that was raised by Jon Jonsson, I think it was. And he said, wait a minute, I wrote it down. We should bring more visibility to our product and explain it better. Wait a minute, yeah? Yes, he said, what we have to do constantly is explain the advantages of district heating and cooling to our customers and to anyone else. We have to explain it. And this kind of certificate is a very easy way to explain and show the advantages. These are the figures. They speak for themselves. You want to see the last two slides about what we do in Germany? I know you like the slides, Niko. We have implemented the EPBD for 10 years ago, over 10 years ago in Germany, and we have primary energy factors in Germany. And the German government decided to use the non-renewable primary energy factor as a minimum requirement for the buildings. And we set up a system of how to calculate it and where to show it. And on our website, there's a list showing primary energy factors. And it looks like this. So it's this set is the city, the network, the utility, and then the primary energy factor in this column of the table. And in addition, in Germany, we have a validity period, and some are already phased out here. The validity is over. But let's say, for example, Cologne. Cologne is a big city that you all know. For example, Innenstadt Deutz, utility Rheinenergie, primary energy, non-renewable primary energy factor is a beautiful 0, and validity until 2020. So the list has already, I think it is 440 German district heating systems on it. And to show the whole picture, because it's about 11 pages long, but the whole picture, I put into the graph, and the graph looks like this. And all the district heating systems, so any of these 440 district heating systems on the list is one dot, one blue dot. And all the 440 form this line. And this shows us some of them, even over hundreds of them, are slightly in the negative, but they are cut to 0. And this is how good we are. So speaking with Jon Jonsson, explain the advantages, and this is what the advantage of district heating may be. Not all systems are very good, but the majority, they are, at least in Germany, with a non-renewable primary energy factor. And I could explain for hours or days what we are doing in the district energy standard and what the calculation of CHP is, but you are lucky. This was my last slide. Thank you for your attention.
Thanks a lot, Boris. I think this illustrates that we have a solution for the energy performance of buildings, but nobody knows it. So, but let's continue. So now we go something that building owners do without any regulation, what they do voluntary basis for the energy performance of buildings. And Robin is going to tell about that. Please, Robin.
Thanks very much, Niko, and good afternoon, everybody. Now then, let's get to the right slide.
I'm as poor as you are with the computers, but I try.
Oh, yeah, okay. I'm going to... Yeah. So, in terms of a building's environmental performance systems, what are they? Why should we use them? We hear these terms BREEAM and LEED most commonly when buildings' environmental performance systems are being spoken about. I am from BRE, so I am going to talk most about BREEAM because, well, for obvious reasons. If we then look at the whys and wherefores, the fact is that the environmental rating of buildings is growing rapidly. And yes, it is voluntary, sort of, and depending where you are, because increasingly, and of course I am talking mostly from the UK perspective, certainly in the UK, increasingly planners are insisting on high efficiency buildings, and so certain BREEAM ratings can be actually predicated if a developer wants to basically develop within a particular town or city. The rating of buildings enables hidden elements to be credited. So looking at something like district heating, it's obviously less visible than something like photovoltaics. So this can work to the advantage of district heating, that it can be credited. Also, at the same time, although these things are, as I say, on paper voluntary, but kind of in the UK, not always, but there are other reasons, other motivations why people have in the past gone for some rating system. For example, undoubtedly getting a good rating is a way of demonstrating your green credentials, and some companies, particularly maybe the blue chip ones, are very much wanting to do that, and also arguably raises the asset value. We, of course, particularly when we're looking at district heating, concerned with community systems. So whereas BREEAM very much started its life as something for individual buildings, and that remains, at the heart of it, nevertheless, there's also the community relevance, which has come in for a range of reasons, but certainly is one that's of importance to district heating. So which one to use? We all, I think, have heard of BREEAM and LEED, and there are certainly others, but those are the two most commonly used systems. I think that I could say confidently that the right decision on this can help to focus and to ultimately end up with a better design and quality of building, and therefore also benefit the future occupants. But as to which one you should use, it's, I suppose, a strange question for somebody from BRE to answer. And I'm going to essentially say that both BREEAM International and LEED US claim global applicability, and that both of them, in doing so, defer to local regulations, guidance, and standards. And following on from that, there has been analysis done, certainly in the UK, maybe elsewhere, to take a look at the two systems. Shows considerable overlap, actually. One analysis showing about 50% commonality. And indeed, if a building scores well with BREEAM, it's probably also going to do well with LEED. I would say that BREEAM targets are often quite technology specific. LEED targets leave it more to designer discretion. I'm going to focus on BREEAM here on in, I think for obvious reasons, that it's something I know more about, but I leave you with the fact that I think that both systems are going potentially to give the sorts of benefits that I set out. I would say one thing about this technology-specific elements that as I and my fellow colleagues, 5 of us that work on district heating and have done so for the last 15 to 20 years, that occasionally issues have cropped up with how district heating gets to be treated within BREEAM, and of course therefore on a kind of unofficial basis, because I'm not in the BREEAM team, we've been able to liaise with our BREEAM colleagues and point out some of the things that have arisen over the years when you are looking at a system which is essentially, as I say, starting its life with individual buildings, and you are really looking at a technology that benefits when there are lots of buildings together. So you can, I think, appreciate that there can be issues in that regard that we've done our best to sort out. Looking though at BREEAM then, it is certainly the world's longest established and most widely used environmental assessment method for the built environment. Was actually created in 1988 and launched formally in 1990. Going towards 500,000 projects certified and almost 2 million registrations for assessment since it was first launched. And BREEAM works by, it's not, you know, everything's done at BRE. There are, people get essentially trained up to become BREEAM assessors. People within BRE, for obvious reasons, are actually not allowed to be assessors. So BREEAM is, if you like, configured and kept up to date and so on at BRE, but we don't do the assessments. So there are 4,000 independent licensed assessors. And having started, of course, in the UK, it's now in many, many countries. So that's across the world, that number. We said that BREEAM is voluntary, but that it's increasingly being used as something for which there is an obligation that planners put forward. It has this independence and credibility, and it does look at a holistic view and is customer focused, and I think that's something that will characterize our competitors as well. Essentially, what it's trying to do is to, of course, get a better built environment. And as such, you see that this graph, which shows the different ratings you can get within BREEAM, pass, good, very good, excellent, and outstanding, all start from the absolute minimum standard, which is where the actual regulations are. So even a mere pass means you've done a little bit better than you absolutely had to. So this is, you know, it's de facto voluntary because it starts and improves upon the regulations if you want to get that particular certification. It did start with the new build environments, individual buildings, and it has now a number of different elements to look across the whole life. So there are parts of BREEAM which are dealing with right from the beginning, right from the outset, the master planning stage. Then at the other end, you've now got BREEAM in use, which, as I say, BREEAM started off with new build and it now is able to deal with existing buildings. As well as dealing with existing buildings, it actually means that for any particular building, you can keep a link with BREEAM because you obviously progress from the master planning stage to getting built to being an existing building that obviously ages as time goes by. So it caters for the whole life, basically, in different parts, different sections of BREEAM. It's important, I guess, to just point out that energy, although it's a jolly important part of BREEAM, is certainly not the only element. So this slide just shows you some of the other issues that I think we would all recognise go very much hand in hand with an excellent built environment. And some of those, of course, very much interlink with energy. In terms of scoring, BREEAM works by a system of credits, and the top green box is all about the minimum standards that you need in order to reach a particular grading. And then when you exceed what the minimum in any category is required, then you can go down to the second box, which is tradable credits, where you can sort of trade one against the other. But essentially, in order to get to, for example, the very good rating, then you have to adhere to a minimum standard in each of those categories, which also gives you a total of at least 55. How then to get those credits? BREEAM basically currently uses a performance approach, and that has displaced the simple checklist. That BREEAM started its life pretty much as a checklist, and now it's moving to a much more performance approach, which involves getting together all the energy-related credits in terms of how that building performs against some national minimum compliance. And of course, that depends on which country you are in. For the UK, there is a system called SBEM, Simplified Building Energy Management System, and it's compared to the designated local minimum requirements in each and every country. So SBEM is just for the UK, but you will have the equivalent in whichever country you're in. So modelling energy performance. First, the energy performance data is gathered. That means the demand, it means the primary energy consumption, carbon dioxide emissions, and this for the actual building and the notional building from the actual calculation tool, the SBEM, the Simplified Building Energy Methodology in the UK, and whatever else it is wherever you come from. That data is fed into so-called translator curves. Again, that varies by country, and from that it's you obtain the metrics which classify the energy credits that you're entitled to. So district heating is part of that story, and how that's dealt with, again, is something which is handled at a individual country level. So as I mentioned to you, we've liaised with our colleagues in terms of the UK, how it gets treated there. And there's a web portal available for the assessor to submit data in order to get these credits. So the BREEAM assessor would use that and come up with the numbers. And across a wide range, this shows one bit of it. You see that a couple of energy categories there down at the bottom, and the credits that enable you to get through to different gradings within BREEAM, from pass to outstanding. And didn't want to go that way. That's it. And in terms of energy, the credits are also broken down into energy efficiency, monitoring, low and zero carbon technologies, and so on. So that is the heart of the BREEAM system. I just wanted to say a word or two about the BREEAM communities, which was the bit that is relevant to master planning, just because it is something that lends itself very much to integration of district heating. Where when there's an individual building, clearly there is this kind of issue of looking at the individual building, but bearing in mind it might be on a district heating system. And to give you just one example of something that happened some time ago, we found that in one particular city which does have, it's not in the Stone Age, to coin the earlier phrase, it's a city with a big district heating scheme. And the local planners were insisting on BREEAM Excellent for a particular development. Only problem was that the building couldn't get BREEAM Excellent if it joined to the district heating scheme, because the district heating scheme was using a waste-to-energy system, and BREEAM didn't think that was, that was a good enough source to qualify as excellent. So you can get those kind of dilemmas. BREEAM communities, however, right at the start, at the master planning stage, very much looking at the whole community from the environmental, social and economic sustainability. So I think it binds in district heating very nicely. And that just shows you, some of you will recognise where that particular exercise takes place from that spiral tower. Anybody help me on that one? Any Swedes? Malmo, yes. Just as an example as well, that we've done sort of work on BREEAM communities in other countries, and I think Malmo was one of the first cities that took that up. So it's a bit of a whistle-stop tour through BREEAM, but I hope that helps to clarify things a little, and thank you for listening.
Thanks a lot, Robin, and now it's time to go to the last presentation that is focused on a customer's perspective. It's not good to forget the customers. In this case, it means the property developer and owner perspective. Please welcome Guido.
Thank you. Thank you very much for the nice introduction, Niko. Ladies and gentlemen, my name is Guido Schwarzendahl, and so we are just waiting for the presentation. Oh, there it is. Thank you. Thank you again. Yes, my name is Guido Schwarzendahl, and I'm the managing director of a housing cooperative in Germany, and I'm also speaking today as a representative of the GDW. So you also see the sign of the GDW on this first slide. And the GDW is the apex organization of the housing companies in Germany. First of all, I will start with a short introduction of the cooperative. In 2006, the cooperative was originated out of a merger of two different cooperatives. One was really an older cooperative established in 1910, so we will now have in October the 105th anniversary of our cooperative. And the other one was a cooperative established in 1954 with prefabricated buildings. Today we are represented at 4 cities in the southern part of Saxony-Anhalt, which was a former part of the GDR. A few figures: the number of dwellings, more than 7,800 dwellings, and we are a rental cooperative in ownership of our cooperative, and additionally there's a subsidiary company which manages the administration of 2,500 condominiums. And to have a look from the customer side, dwellings with district heating supply are 4,660. That's truly more than 50% of all our dwellings, and they are situated in 3 cities in Saxony-Anhalt with 3 different suppliers, and so I think we are a very experienced district heating customer. Our cooperative was affected very much by the massive shrinking process in the former GDR. We are an active partner in the heating shrinking process, and we managed the demolition of nearly 1,900 flats, and in the same time, in the last 12 years, the refurbishment of more than 1,100 flats. Our current status of modernization of buildings is 70% totally modernized, 30% partially modernized, and it's only the number of 8 flats which is not modernized up to now. And there's a little mistake. It's not more than 1,231. It's exactly 1,231 flats are situated in listed buildings. They are protected building heritage, and 100% of them are modernized. And so you can see on the small pictures, perhaps that works. No, you can see it on the pictures. That are pictures from the 1920s, from the erection of the building over the time of the GDR up to now, and you see very nice buildings. As I already told you, we are an active partner in urban redevelopment. We managed the demolishing of a building, as you can see on the right picture, a high-story building, a prefabricated building, and in the settler town of Halle Neustadt. And on the other side, we made the refurbishment. And so you can see it on the other picture. It's a massive insulation on a prefabricated building up to our day's standards. And when we demolished these buildings, this means, on the other hand, the loss of supply of more than 100,000 square meters living space, and all of these square meters were supplied by district heating. And that means, to give you an amount, or a yearly amount of the heating demand, it's nearly 12,000 megawatt hours a year. And that's quite a lot. What's the principal advantage and challenge of district heating? Following my opinion, the principal advantage is no air pollution at the place of delivery and consumption of the heat. And the cogeneration, we already heard about it, with the carbon dioxide reduction, which is essential for new building standards and the higher KfW. KfW is the development bank in Germany, subsidies for energy-related modernization. Due to the historical evolution of city development, the former GDR, where we have our flats, is still better supplied with district heating systems. According to the already mentioned GDW, 3/4 of all residential buildings of housing companies in the former GDR use district heating. They're absolutely used to it, while less than 1/3 uses district heating in the former Western Germany. That's quite a difference. So in the former GDR, there are very strong ties, absolutely very strong ties between housing companies and usually the municipal works, which delivers the district heating. And the challenge for both of us is the shrinking number of houses and, on the other hand, the higher efficiency of the remaining buildings due to the refurbishment of these buildings. Both result in a significant loss of consumption. Housing cooperatives have to face the discussion of sustainability in Germany and in general are forced to lower their energy consumption. Energy system transformation goals in Germany are, for example, up to 2020 to lower 20% of heat requirement and up to 2050 climate neutral. This means a decrease of 80% primary energy consumption up to this time. And we will only manage these high goals or issues if we double the energetic modernization in our residential buildings from 1% per year up to 2% per year. And as I already mentioned, big goals need a strong partnership, and these are indeed big goals, especially for the housing companies in Germany. And in the satellite towns of Halle, district heating is widely spread. Nearly 100% of the residential buildings are supplied by district heating. And on the other hand, a lot of these buildings still need a refurbishment. And so we will lose again the demand of district heating. To show you the strategy of housing companies, first of all, you can see a graph which looks very much like a Boston Consulting Group portfolio graph. And I try to show you with this picture what is the problem for us. We are always interested in low investment cost, and we are absolutely interested in high energy cost savings for our tenants. And as you can see on this one, I have no idea how to manage it to get by low investment costs, high energy cost savings. And so we have to concentrate more on this point. And that means low investment cost and low energy cost savings by plant optimization, by contract optimization with the district heating suppliers, and by the user behavior. And it's the energetic strategy of the housing sector to reduce consumption under economically viable conditions, to advise the tenants, that's the user behavior, in energy optimized behavior, to cover the remaining consumption by renewable energies, which will be high investment costs and will only be low energy cost savings. And as a conclusion, we need fair and functional competition, guaranteeing reasonable prices for the heat supply. What are the main issues of the housing sectors? In the event of new construction and modernization of residential buildings, housing companies have to decide for the most beneficial heating option. The potential, the already mentioned potential of cogeneration by Boris, meets the requirements of the German building laws to fulfill new building standards. District heating companies have already seen the advantages for the housing sector and calculated and communicated the low primary energy factors to satisfy the regulation of the German Energieeinsparverordnung, abbreviation is ENEF, which means the Energy Savings Ordinance. We have already seen the tables by Boris with the low primary energy factors. A problem is that due to the grid-bound system, district heating is not everywhere available. That's indeed a restriction for new construction, and that's a big disadvantage, especially for our cooperative, and a disadvantage for the district heating supplier is a comprehensive modernization of residential buildings I've already mentioned within the grid. This leads to decreasing energy consumption for the district heating supplier, and on the other hand, in the most cases, to increasing prices for the customers. In German cities, municipal works often uses district heating priority statutes to prevent an economic dilemma. Grid-bound systems and the security of investment on the one hand, and fair and functional competition in supplying heat for the housing sector on the other hand. Even in Halle, the municipal works use such a district heating priority statute, and I think it's not the way for the future. And because the housing sector therefore aims for a more flexible and affordable solution. I want to remember that the district heating is a highly estimated supply system. A permanent threat are increasing prices due to the modernization of buildings or the shrinking number of buildings to supply. Super important will be the combination of grid-bound systems and local systems for heat supply. Both must not compete, but should be a potential market of the future for the district heating suppliers. I'm convinced that district heating suppliers should take into account the future needs of the housing sector. And when I'm convinced on the one hand, there's a principle, or there could be a principle on the other hand. The housing sector is naturally ally to the district heating suppliers, and perhaps to compare it again with the metaphorous Cinderella picture of Boris, perhaps the housing sector can sometimes be the prince of the bride and not the prince of Cinderella. Thank you very much for your attention.
Thank you, Guido. It's good to know that there might be a good combination between real estate sector and the district energy sector. But now, everyone, please ask any questions to anyone. I think there.
Thank you. Ulrika Jardfeldt from the Swedish District Heating Association. I have a question for Mrs. Hus. In your presentation, you showed about the results of the Energy Performance Buildings Directive. You showed an image on the impact of renewables. In your graph, since this is a district heating conference, and I'm a resident of Stockholm, which has a lot of district heating and also a lot of renewables, according to our view, you show that we had an extremely low share of renewables. looking closer in your graph, I saw that it actually reflected the solar on-site share that the directive had resulted in. So I was just wondering if the Commission has any preference on, I mean, solar on-site versus bioenergy supplied by a district heating system. Is it, I mean, or was that just a mistake in your presentation?
No, this is really just an example. We are still evaluating and working with the national notifications. So this is just an example. And this is basically one example of possibilities on on-site renewables. That's not even from district heating. It doesn't show any preferences whatsoever.
Okay, the next one. There is another one.
My question to Boris, how could district heating be in some cases at least, it was worse than fossil fuels, and I wonder how could it be possible?
Hello? Yeah. The very low numbers for fossil fuels for the heating is the effect of the combined heat and power. Because in combined heat and power I have only one fuel in, two products out, I have to allocate it. So the numbers for at least one of the two products will be very low. That's the CHP effect. Did I?
Why do you have high numbers in some cases? In most major part of the examples or the plans, for the plans, you had much lower than fossils. But in some points at the top of the curve, you had actually some plans with higher primary energy factor than fossil. And that's confusing me.
They are based on a model saying we have only a heat-only boiler, no cogeneration, fossil fuel input, rather low efficiency, grid losses, and so we get a value that we can really call being conservative. Because one of the principles in the standardization here is if you do a calculation with all the real data input, it should be rewarded by better results. So the option 1 default values should be conservative. And anyone who uses the default values doesn't have really better numbers, better values, then his real performance would be if he calculates. That's the principle behind it.
Okay, more question? Just in time, okay. So before I close this session, there is one practical announcement related to this closing remarks and farewell drinks. They are just behind that exhibition area in this Congress floor. But now I would like to thank you, all of our speakers, about the excellent information related to this issue, and of course the audience. This was the second day afternoon, and you were still listening quite carefully. Thanks for everyone, and have a good continue of this afternoon.